Alrighty, so in this section here, we're going to figure out what makes triangles congruent. I call those the triangle congruence shortcuts. And the question is, do we need to measure all three sides and all three angles on two different triangles to see if they're congruent? You probably remember the definition of congruent figures, congruent polygons, whereas all the sides were congruent and all the angles are congruent. So what's the minimum we need to show? Obviously, we need to show more than one side in each triangle congruent, or more than one angle in each congruent. You just learned in the triangle the triangle side inequality conjecture that if you had two sides of a triangle, like 6 and 11, that this third side could be anywhere between 5 and 17. So there's lots of triangles, so 2 are no good. So what I want to try is I want to see if maybe we can do 3 different pairs of sides, or 3 different pairs of angles, or some kind of a combination of those. So the 3 that we're going to choose to take a look at are what we call side, 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 which is where 3 sides in one triangle are congruent to 3 sides in another triangle. We're also going to take a look at side, angle, side. We abbreviate that SAS. So notice that it's 2 pairs of congruent sides and 1 pair of congruent angles. We call this the included angle. So please notice that the included angle in this one on the left is the angle that's formed by the 2 congruent sides. That's what we mean by an included angle. So when we say it's like side, angle, side, that's why the A is between the 2 S's, because the angle is between the 2 sides. And we're also going to investigate side, side, angle. So notice in this one that the congruent angles are the non-included angles. They can be in one of 2 spots. We choose to put them on that side of it. So you have a side, and an angle that's not formed by the 2 congruent sides. So to investigate this, we're going to play with Geometry Sketchpad a little bit. So let me open up a Geometry Sketchpad for us. So what I have here is I have triangle ABC, and I'm going to try to build a triangle DEF. And I should be able to get it congruent, but I'm wondering, can I get any other triangles? And please notice that all of these sides are congruent to each other. As I move point C around, point F is going to move correspondingly, and the same with those sides there. So what I'm going to do is I'm going to kind of build this triangle here. Let me put the point D's together. There we go. And I'm going to drag these sides together. And I know what you're saying. You're like, wait, they don't fit. Well, I can put this wherever I want. Remember, the angle really isn't part of it here. So I'm just going to keep moving that around for a minute until I get it so it looks like they're about on top of each other. Let's see, can I get the other angle? The other point F? There we go. There we go. That looks pretty good. Now, if I drag this triangle over here and pop it up on top, it looks like they're exactly the same size. All the angles are the same size. All the sides are the same size. And I can't build another triangle. I mean, granted, I can take this maybe and put it over here, but that doesn't make sense because now I'm putting point E on point D. So side, side, side is a valid shortcut. If you know that 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So we'll say this one is good. Side, side, side is a valid way to prove triangles congruent. The next one is side, angle, side. And if we take a look at this figure here, again, I have triangle ABC, and I got part of triangle DEF. And what I want you to notice is that I'm going to make it in such a way that all of the sides stay the same length, the corresponding sides, and the corresponding angles do as well. So I have a side, angle, side relationship. And as you can see, there's really only one other triangle I can do. The only thing I can do is I can connect point E and point F together. And then these 2 triangles are congruent. So side, angle, side is another great shortcut. So side, angle, side is good. One more to try. The last one we're going to try for today is side, side, angle. And you might look at it and be like, oh yeah, look at that. Perfect fit. But here's where it breaks down. I'm going to grab onto this point F, and I'm going to extend. That's how, remember, this side of DF can be whatever I want it to be. So if you notice in these two triangles, I've still made a side-side angle relationship. If I can drag this triangle here, let me grab onto it for a second. Notice that those two sides are still the same. The angles are still the same measure. And angle or side EF and side BC are the same length. If I move the other F down here, let's move the other F down. Oh, there we go. Please notice that I haven't changed the length of side EF. So BC and EF are still congruent. I have a side-side angle relationship, and I've made two completely different triangles that are not congruent. So guess what? Side-side angle is no good. And you know another reason why it's no good? Spell that backwards. That's why it's no good.